Tighten the nut to snug, and then push outward on the rotor blade straps to seat the thrust block against the thrust washer. Then tighten the bolt. Do not torque this bolt at this time. Do the static lead lag adjustment. Make sure the main shaft is level both lateral and fore and aft. Make sure the hub plate is level laterally. Each blade must be level in relation to the lead lag position and must float freely on the pitch pins. To make the proper lead lag adjustments, level each blade by loosening the set screws and the two 5/16" bolts that secure the liner block. Then adjust the blade by either leading or lagging it with the all-thread 1/4" bolts. Use a level on the blade strap. Switch back and forth from bolt to bolt to maintain a level static lead lag adjustment. Next, tighten the two liner block 5/16" bolts. Then tighten the 4 set screws. Always monitor the level on the blade strap to maintain a level static lead lag adjustment. This can be a sensitive adjustment as you tighten the bolts and set screws against each other. Reference the construction print E20-2000 for the final torques of the 1/4" all-thread bolts, the 5/16" liner block bolts, and the set screws. Make sure the level bubble is in between the lines after you have torqued the bolts. With the blades teetering freely, Set the end plugs and their wood screws on the ends of the blades. The tip weights and their screws and nuts must be in their position. Teeter the blades. The hub will return to a level position if the static balance of the blades are equal. Notice the slave blade on this ship is slightly heavier. Weight will have to be removed until the hub is level. Install the tip weights. Install the end plugs using 3M structural adhesive and the wood screws as per the construction print. Replace the two 3/8-inch teeter block bolts one at a time to prevent excess strain on the other teeter block from the weight of the two main rotors. Place a small amount of grease on the bolt threads and drive the bolt in. Torque bolts to 24 foot-pounds. Install two 5/16-inch bolts in the pitch horn clevis that have been ground to a point. Lift the pitch horn high enough to allow the point of the bolt to touch the main drive pin. Rotate the pitch horn and clevis by tapping lightly with a mallet to align the point of the bolt with the center of the drive pin. Connect the control rods between the pitch horn clevis and the rotating swash plate. Use two long 5/16-inch bolts of the same length in the rotating swash plate when installing the control rods. Place a straight edge and a level on the bolts extending from the swash plate. Level the swash plate. Adjust the control rods to level and cord line of each blade. The hub plate must also be level at the same time. Measure the distance between the main shaft and the control rods even with the bottom of the hub plate. The distance must be the same on both sides. Mark the retention strap with the two 3/16" holes that will be drilled that secure the pitch horn to the top blade straps. Do not drill these holes while the blades are mounted to the rotor hub. You will be instructed to remove the blades shortly. Make sure the main shaft is 90 degrees to the ground, fore and aft. Then slide the rubber shaft protector on the main shaft upward. Teeter the blades so that they are 7 1/4 degrees to the shaft. Slide the rubber down until it rests on the strap, and mark the edge of the bottom strap. Do the same teeter the opposite way and mark the edge of the other strap. Remove the blades and drill the 3/16" bolt holes and trim off the retention strap where marked. Install the pitch horn to the blades with the two 3/16" bolts. Check the fit of the 9/16" bolt. The main rotors will be reinstalled in Section 25 rigging. Engine first start preparation and procedures, along with the testing of the main rotor system, will be included in an expanded Section 26. Review all of the construction prints and follow the details of this section thoroughly. Although many details may repeat previous instructions given throughout the videos and manuals, Rotorway feels that this is absolutely necessary to stress the importance of the rigging procedures. The battery should be disconnected at this time. The purpose of the tail boom is to hold the trim fins and the tail rotor in the desired location. If the trim fins and tail rotor are not in the proper location and set at the correct angle, the helicopter will not respond correctly in flight. To have the best stability, the following angles and distances must be correct. The angle of the top of the tail boom should be 2.5 degrees more than the angle of the square drive tubes in the airframe. The horizontal trim fin chord line should be parallel with the top of the tail boom. The vertical trim fin chord line should align 15 inches to 16 inches to the pilot side from the center of the main shaft. To verify that the chord line of the horizontal trim fin is parallel with the top of the tail boom, measure the thickness on both the leading edge and trailing edge. Divide each measurement by 2 to find the distance from the top of the fin to the chord line at that point. For example, the leading edge measures 980 thousandths, divide that by 2, and you get 490 thousandths. The trailing edge measures 88 thousandths, and divided by 2 equals 44 thousandths. Subtract the smaller number from the larger number, and you get 446 thousandths. Sand or grind a small piece of the wood to that thickness to be used as a spacer. Place the spacer on the trailing edge. Rest the protractor level on the leading edge and the spacer. The protractor is now parallel with the chord line of the fin. Check that the chord line is parallel with the top of the tail boom. To verify that the vertical trim fin is at the correct angle, tape a piece of welding rod on the front and rear of the fin, extending about 1 inch. Sight across the welding rods from behind the ship. The rods should align between 15 and 16 inches to the pilot's side of the main shaft. The purpose of the cyclic control is to maintain the balance of the helicopter when it is in the air by tipping the swash plate. If the angles are not within the specified range of travel, the sensitivity of the control will be affected, possibly to the extent of being unable to control the helicopter. The angles that will give the pilot the best control throughout all maneuvers are as follows. The total travel from the left to the right stop should be 52 degrees, with equal number of degrees both directions from the center position. The total travel from the rear to front stop should be 52 degrees, with the rear stop set for pilot comfort. Note the cyclic control must tip the swash plate to the correct angle in reference to the main shaft for proper control of the helicopter. Set the protractor to read 26 degrees and place it on the side of the cyclic handle. Move the cyclic to the left until the bubble centers. Adjust the stop bolt so it makes contact with the cross shaft. Set the protractor to read 26 degrees in the other direction, leaving it in place on the side of the cyclic. Move the cyclic to the right until the bubble centers. Adjust the stop bolt so it makes contact with the cross shaft. Set the protractor level to read 26 degrees and place it on the rear of the cyclic stick. Move the cyclic to the rear until the bubble centers. Adjust the rear stop bolt against the stop bracket. Set the protractor level to read 26 degrees in the other direction and move the cyclic forward until the bubble centers. Adjust the forward stop bolt against the forward stop bracket. The purpose of the collective is to control the amount of pitch on the main rotor blades and the amount of throttle on the engine, which determines how much lift you have to work with. To obtain the best control of both items, the pitch of the blades and throttle, the collective control must be set up as follows. The collective control must have freedom of movement throughout its full range of travel, from the bottom of the pocket in the floor pan to where it contacts the airframe bracket. The throttle is checked by placing the collective in the full down position and twisting the throttle from stop to stop. The throttle transfer rod should rest on the fore-aft throttle shaft at each end of travel. The collective should travel a minimum of 16 inches from full down to full up position, measured from the center of the handle. The purpose of the anti-torque pedals is to control the pitch of the tail rotor blades. Changing the pitch on the tail rotor controls which way the helicopter will turn. To have enough control in all maneuvers and power settings, set the pedal travel as follows. The anti-torque pedal control should have freedom of travel from stop to stop, with the push-pull cable traveling 2 7/8 inches. These are the stop bolts used to set the travel of the pedals. Push the left pedal to the stop. The tail rotor directional cable should move forward. Push the right pedal to the stop. The tail rotor directional control cable should move to the rear. The total travel of the cable should be 2 7/8 inches. The purpose of the tail rotor is to counter the effect of torque. If the tail rotor does not work properly, the helicopter will turn as soon as it becomes light on the skids, and there would be no way to stop it. Follow these steps when rigging the tail rotor. The key in the tail rotor shaft should extend the same amount out of the slider at each end of travel of the pedals. Note, to prevent lockup, the key must not extend more than 5/16 of an inch out of the slider. Reference construction print E17-2001 to fabricate from a 1/2 to 3/4 inch thick piece of wood this pitch checking template as shown. Place the arm in the full negative position. Note, the key should not extend more than 1/4 of an inch to 5/16 of an inch. Adjust each pitch length to 8 degrees reading as shown. Rotate 180 degrees to check the second blade. Adjust both blades as close as possible to 8 degrees negative pitch within 1/2 turn on the pitch link. After the negative adjustments are made, push the right pedal to its stop and check the pitch on both blades and verify that they are 24 degrees positive pitch.